Thank you, Ms. Duroy. So now let's talk about the normal distribution. What is normal distribution? Normal distribution is a continuous, symmetric, and bell-shaped distribution of a variable. It is also a graph depicting the normal distribution which has shape reminiscent of a bell. The top of the curve shows the mean, mode, and median of the data collected. So just like in figure A, B, and C, we can see that the shape of the graph is like a bell. And the shape and the position of a normal distribution curve depend on two parameters that mean the standard deviation. So each normally distributed variable has its own normal distribution curve, which depends on the values and the variable's mean and standard deviation. Figure A shows two normal distributions with the same mean values but different standard deviations. The larger the standard deviation, the more dispersed or spread out the distribution is. While figure B shows two normal distributions with the same standard deviation but with different means. These two curves have the same shapes but are located at different positions of the x-axis. And also in figure C, it shows two normal distributions with different means and different standard deviations. So sa figure A, makita na to nga same means but different standard deviation. So lahi ra ang shape sa draw nga sa bell shape nga draw sa figure A. Same as sa figure B, different means but the same standard deviation. So bale parehas sila og shape pero lahi ang ilahang means. And the figure C shows the different means and different standard deviation. So ilang curves is different ang pagga-draw and different sa ang ilahang means. So next is the summary of the properties of the theoretical normal distribution. So first is a normal distribution curve is bell-shaped. Second, the mean, median, and mode are equal and are located at the center of the distribution. Third, a normal distribution curve is unimodal. It has only one mode. Note that it has only one mode. Fourth, the curve is symmetric about the mean, which is equivalent to saying that its shape is the same on both sides of a vertical line passing through the center. Fifth, the curve is continuous. That is, there are no gaps nor holes. For each value of x, there is a corresponding value of y. So 6, the curve never touches the x-axis. Theoretically, no matter how far in either direction the curve extends, it never meets the x-axis, but it gets increasingly closer. So 7, the total area under a normal distribution curve is equal to 1 or 100%. This fact may seem unusual since the curve never touches the x-axis, but one can prove it mathematically by using calculus. So the normal curve that lies within one standard deviation of the mean, it is approximately 6.68 or 68%. And in the standard deviation 2 or in the 2 standard deviation, we can see that it is 0.95 or 95%. And in the 3 standard deviation, it is about 0.99 or 99.7%. So next is the standard normal distribution. What is standard normal distribution? It is a normal distribution with a mean of 0 and a standard deviation of 1. So since each normally distributed variable has its own mean and standard deviation, as stated earlier, The shape and location of these curves will vary. In practical applications, then you would have to have a table of areas under the curve for each variable. To simplify the situation, statisticians use what is called the standard normal distribution. So the values under the curve in the figure which is shown in the figure, it indicates the proportion of area in each section. For example, the area between the mean and one standard deviation above or below the mean is about 0.3413 or 34.13%. And the formula of the standard normal distribution is y equals e to the power of negative z squared divided by 2 over square root of 2 times pi. All normally distributed variable can be transformed into the standard normally distributed variable by using the formula for the standard score. So z equals value minus mean over standard deviation. So as stated earlier, the area under a normal distribution curve is used to solve practical application problems. So now, let's talk about finding the areas under the standard normal distribution curve. So how would we find the areas under the standard normal distribution curve? So, for the solution of problems using the standard normal distribution, there are steps or procedures that are recommended with the use of the procedure table shown. So in the procedure table, in finding the area under the standard normal distribution curve, first is to find of any z value. So look up at the z in the table and use the area given. Second is to the right of any z value, look up the z value and subtract the area from 1. Third is between any two value, look up both z values and subtract the corresponding areas. So, in the figure in table A gives the area under the normal distribution curve to the left of any z value given in two decimal places. So for example, the area to the left of AZ value is 1.39 is found by looking up 1.3 in the left column of 0.09 in the top row. So where the two lines met gives an area of 0.1977. So let's find the area to the left of z.199 or 1.99. So first step is to draw the figure of the desired area. So second step is we are looking for the area under the standard normal distribution curve to the left of z equals 1.99. Since this is an example, so the first case is to look up the area in the table. It is 0.9767. Hence, 97.67% of the area is less than z equals 1.99. So this is how we find the area to the left of z equals 1.99. So now, let's proceed in finding the area to the right of z equals negative 1.16. The first step is to draw the figure of the desired area. Second step is we are looking for the area to the right of z equals negative 1.16. So in this example of the second case, look up the area for z equals negative 1.16. So it is 0.3770 or 0.3770. Subtract it from 1.00 and So so we will come up with a result of 0.8770. Hence, 87.70 of the area under the standard normal distribution curve is to the left of z, which is negative 1.16. So let's proceed to in finding the area between z equals positive 1.68 and z equals negative 1.37. So first step is to draw the figure of the desired area. And second, since the area desired is between two given z values, look up at the areas corresponding to the two z values and subtract the smaller area from the larger area. So the area for z equals positive 1.68 is 0.9535, and the area for z equals negative 1.37 is 0.0853. So the area between the two z values is 0.9535 minus or subtracted to 0.0853, and the result will be 0.8682 or 86.82%. So that's how we will find the value for z. So now let's proceed to a normal distribution curve as a probability distribution curve. So a normal distribution curve can be used as a probability distribution curve to normally distributed variable. So recall that a normal distribution is a continuous distribution. And the fact that it is continuous means that there are no gaps in the curve. So in other words, for every z value on the x-axis, there is a corresponding height or frequency value. The area under the standard normal distribution curve can also be thought as a probability. So that is, if we were possible to select any z value at random, the probability of choosing one, say 0 and 2.0, so it would be the same as the area under the curve between 0 and 2.0. In this case, the area is 0.4772. Therefore, the probability of randomly selecting any z value between 0 and 2.0 is 0.4772. The problems involving probability are solved in the same manner as the previous examples involving areas in this section. So for example, if the problem is to find the probability of selecting a z value between 2.25 and 2.94. Solving this, we will use this method. For probabilities, a special notation is used. For example, if the problem is to find the probability of any z value between 0 and 2.32, this probability is written as the probability of z is greater than 0 but less than 2.32. And note that in a continuous distribution, the probability of any exact z value is 0 since the area would be presented via vertical line above the value. But vertical lines in theory have no area, so the probability of z is greater than or equal to a but less than or equal to b, or equals the probability of z is greater than a but less than b. So now let's find the probability of z is greater than 0 but less than 2.32. So solution. This means, first is z is greater than 0 but less than 2.32, and this means that to find the area under the standard normal distribution, curve between 0 and 2.32. So first, let's look up at the area corresponding to 2.32, and now it is 0.9898. So then, look up at the area corresponding to z equals 0, and it is 0.500. Then, subtract the two areas, which is 0.9898 and 0.5000, and the result will be 0.4898. Hence, the probability is 0.4898 or 48.98%. So now let's proceed in finding the probability of z is less than 1.65. So first, look up at the area corresponding to z equals 1.65, and it is 0.9505. Hence, probability z is less than 1.65 is equals to 0.9505 or 95.05% or 95.5%. So next, let's find the probability of z is less than 1.91. So again, let's look up at the area that corresponds to z equals 1.91. And now, it is 0.719. So now, let's subtract this. So probability of z is less than 1.91 is equals to 1.000 minus 0.9719 is equals to 0.0281 or 2.81%. So sometimes one must find a specific z value for a given area under the standard normal distribution curve, or the procedure is to work backward using the table E. So since the table E is cumulative, it is necessary to locate the cumulative area up to a given z value. So now let's try to find the z value such that the area under the standard normal distribution curve between 0 and the z value of 0.2123. So let's try to draw the figure. So in this case, it is necessary to add 0.5000 to the given area of 0.2123 to get the cumulative area of 0.7123. So let's look up in the area in table E. And the value of the left column is 0.5 and the top of value is 0.06. So the positive z value for the area z is equals to 0.56. So next is to find the area in table E. Then read the correct z value in the left column as 0.5. So, and in the top row as 0.06. And add these two values to get 0.56. So before I give the stage to the next reporter, let me present to you the z table where we refer in finding the area value for z. So that would be all. Let me give the stage to the next presenter, Ouija Braille Diola. Ouija.